Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 3 Paper 2 Code ENF Physics. Let's move to question number 1. In question number 1, in Young's double slit experiment, the 8th maxima with wavelength lambda 1 is at a distance y1 from central point of screen, and 5th maxima with wavelength lambda 2 is at a distance y2. Then separation between y2 and y1 is delta y, where d is the distance of screen from the slits and small d is the slit separation. So we know that the position of the nth maxima from the central point is given by y is equal to n times lambda capital D by small d. So we can say that y2 can be written as 5 times lambda 2 capital D by small d, and y1 can be written as 8 times lambda 1 capital D by small d. So if I find out the separation y2 minus y1, that is equal to capital D by small d into 5 times lambda 2 minus 8 times lambda. So option A is the correct answer. Let's move to question number 2. In question number 2, an object is placed at a distance 20 cm from an equiconcave lens of focal length 30 cm. If one of the concave surface is to be polished, then position and nature of the final image will be, and it is given that radius of curvature of surface is 60 cm. So in this problem, first refraction takes place through this curved surface, then reflection takes place through this convex surface, then again refraction takes place through this curved surface. So in order to apply the formula of refraction through curved surface, we should know what is the refractive index of the given concave lens. So in order to calculate the refractive index of given concave lens, I have to apply a lens formula, that is mu f is equal to mu 2 minus mu 1 into 1 by r1 minus 1 by r2. So if I substitute the data, f is minus 1 by 30, that is equal to mu 2, which I have to calculate, mu minus here is mu 1, and that can be written as this r1 is minus r and this r2 is r, so it can be written as minus 2 by 60. So if I solve this, the value of mu comes out to be 2. Now if I apply the refraction through curved surface first, then the value of mu 1 is 1, the value of mu 2 is 2, the value of u is minus 20 centimeter, and for this the value of r is minus 60. So if I substitute the data, in mu 2 upon v minus mu 1 upon u is equal to mu 2 minus mu 1 by r. Then I find the value of, this is my first image v1, so the value of v1 comes out to be minus 30 centimeter. So in this case, the first image is formed at this position. This is my I1. Thereafter, this image will act as an object for this concave mirror, and for the convex mirror, I can say that u is equal to minus 30, and for this convex mirror, the value of r or focal length is plus 30, because focal length is r by 2. So if I apply the formula 1 upon v plus 1 upon u is equal to 1 by f, where v is v2, then the value of v2 comes out to be plus 15 centimeter. It means that the second image is formed at this position I2, and this separation is 15 centimeter. Now, so if I draw the ray diagram, then from object the ray falls on this surface and it bends towards the normal, so it will bend in this direction, and the first image is formed at this point, which is in virtual nature. Now at this point the reflection takes place, so the ray will move in this direction and it appears to come from this point. So the image by the convex lens is formed at this position I2. Now for this surface, this I2 will behave as an object. So for the second refraction from the first surface, I can say that the value of u is equal to minus 15 centimeter, because as per convention we have to take the positive in the direction of the incident ray. So in this case, the direction of incident ray is this, so this direction is considered to be positive. So U is taken as minus 15. In this case, the value of mu1 is 2, the value of mu2 is 1, and the value of R. So the center of curvature of this curved surface is in this direction. So the value of R is considered to be plus 60 centimeter. So again, if I apply the formula mu2 upon V minus mu1 upon U is equal to mu2 minus mu1 by R, then the value of V3 comes out to be minus 20 by 3 centimeter as per this convention. So as per this convention, it means that the ray bends away from the normal. So if I trace in the backward direction, then the final image I3 is at this position, and this separation is 20 by 3 centimeter. So as per given xy axis, the value of x coordinate is plus 20 by 3 centimeter. So plus 20 by 3 centimeter is this and this. Now, as we can see, the final refracted ray does not intersect, so it is a virtual image. So it is virtual, erect, as well as diminished. So option D is correct. Let's move to question number 3. In question number 3, a moving hydrogen atom collides head-on with another stationary hydrogen atom. Before collision, both hydrogen atoms were at their own ground state. The minimum value of kinetic energy of moving hydrogen atom in electron volt such that one of the hydrogen atom jumps to first excited state is. So in this case, for inelastic collision to occur, we can say that kinetic energy half into reduced mass of system into V relative square must be greater than or equal to the energy difference, that is delta E. So if I write the reduced mass of the system, then half into both masses are same, so reduced mass is m by 2, and if I calculate the V relative, one of the hydrogen atom is at rest and the another is moving with velocity v naught let, then I can write v naught square is greater than or equal to the change in energy, that is delta E, for the first excited state can be written as 10.2 electron volt in case of hydrogen atom. So from this I can find out the kinetic energy of the moving hydrogen atom, that is half into m into v naught square, that is greater than or equal to 20.4 electron volt. Now in the question it is asked to calculate minimum value of kinetic energy of moving hydrogen atom. So the minimum value would be written as 20.4 electron volt. So option C is the correct answer. Let's move to question number 4. In question number 4, a heavy nucleus at rest disintegrates by emitting beta particle and gamma rays such that the daughter nucleus remains at rest. Which of the following is true for the process? So option A is direction of beta radiation and gamma rays are in opposite direction. So if the daughter nuclei is at rest, it means it is only possible when the linear momentum of the system is conserved. So in order to conserve the linear momentum, the beta radiation and gamma rays must move in opposite direction. So option A is correct. Let's move to question number 5. In question number 5, the diagram shows an AC circuit with two voltage sources of same frequency. Find out the value of current I shown in the figure. So we have to find out the value of I in this branch. So if I apply the superposition principle, then if I draw the diagram in this way, let this is my first source and its potential is V naught cos omega t. Let this is an inductor coil and this is resistor R. First I am taking this way. So in this way, if is at higher potential, it is at lower potential, let the current in this branch is I1, and since the potential between these 2 points is same as the potential between these 2 points, so I can write the value of I1 is equal to V naught cos omega t divided by R. Okay. Similarly, if I see the circuit in this way, that this is resistor, this is source whose value is 3 V naught cos omega t plus pi, and the direction of current is let I2 in this direction. This is inductor coil and this is, since this coil is short circuited, so the value of I2 can be written as 3 V0 cos omega t plus pi divided by R. So as per given question, the value of I must be equal to I2 minus I1. So if I substitute the value of this and so on, I will get answer minus 4 V0 by R into cos omega t. So option B is the correct answer. Let's move to question number 6. In question number 6, the time period of a spring block system is given as t is equal to 2 pi under root m by k, where m is the mass of the block and k is the spring constant. If t and m are measured as this and this, then maximum percentage error in calculation of k is. So from the formula of the time period, we know that k is proportional to m by t square. So if I find out delta k by k into 100, that is equal to delta m by m into 100 plus 2 times delta t by t into 100. So if I substitute the data, so delta m is 1 by 100 into 100 plus 2 times delta t is 0.1 divided by 20 into 100. So if I solve this, it comes out to be 2%. So the maximum percentage error in calculation of k is 2%. So option A is correct. Let's move to question number 7. In question number 7, when some drops of oil is spread on water surface, it displays beautiful colors in daylight because of. Since it is a phenomena of interference in thin film, so the correct option would be interference of light. So option B is the correct answer. Let's move to question number 8. In question number 8, the current carrying wires are parallel and ampere loop is in a plane perpendicular to wires. The magnetic circulation along the loop is in SI units. So from ampere circuital law, we know that line integration of B dot dl is equal to mu naught into summation I, that is the current enclosed. So the direction of positive current is determined by the right hand. So if I curve the fingers of my right hand in the direction of the loop, then thumb represents the direction of the positive current. So if I see first loop in which the 2 ampere current is passing, if I curve my fingers of right hand in the direction of the current, then the thumb moves in the direction of the 2 ampere. So this current is taken as positive. And in the second loop, when I curve the fingers of my right hand in the direction of the current, then thumb represents the direction of positive current. So in second loop, 5 ampere is the positive current and 3 ampere is the negative current. So I can say that this is equal to mu naught times 2 plus 5 minus 3. So it is equal to 4 times mu naught. So option C is the correct answer. Let's move to question number 9. In question number 9, a ray of light is incident on the interface of two media. Angle of incidence is alpha and angle of refraction is beta as shown in the figure. If wavelength of light in medium 1 is lambda, then wavelength of light in medium 2 is. So from Snell's law, we can say that mu1 into sine alpha is equal to mu2 into sine beta. Now, mu is the ratio of the speed of light in vacuum to the speed of light in medium. So it can be written as C divided by speed of light in medium can be written as frequency nu into wavelength lambda into sine alpha is equal to C divided by nu, frequency remains same, into lambda dash into sine beta. So from here, the value of lambda dash comes out to be lambda times sine beta divided by sine alpha. So option D is the correct answer. Let's move to question number